Why is USB Type-C the best choice for fast charging? Hey, engineering enthusiasts! Today we're going to unravel one of the great mysteries and wonders of modern engineering. Why did USB-C become the king of fast charging, allowing power levels that were once unthinkable for such a compact connector? When we think about charging our devices, speed is a crucial factor. But what really allows USB Type-C to deliver so much power in such a short time? The answer lies in a smart combination of physical design and advanced communication protocols. Unlike its predecessors, USB Type-C was designed from the start to handle much higher power demands. It's not just a reversible and convenient connector, it's a true miniature powerhouse. But how does it manage to do that, overcoming the limitations of other connectors that barely reached 10 or 15 watts? Well, the capacity of a connector to carry power is directly related to its internal construction and especially to the size of its conductive paths and conductors. Imagine a road. The wider it is, the more cars can pass through it at the same time. And in the same way, the pins and traces inside a USB Type-C connector have been redesigned to be more robust and numerous. While older connectors had few pins dedicated to power and were thin, USB Type-C has 24 pins. Many of them are dedicated to power and grounding functions and are physically more capable of supporting higher electrical currents. This means that more electricity can flow through them without overloading the system. But is just having wider conductive paths enough to ensure fast and safe charging? Yeah, it's not just a matter of size, but also of how that energy is managed. One of the biggest engineering challenges in fast charging is electrical resistance and the resulting heat dissipation. Electricity, when passing through a conductor, encounters a certain resistance, and that resistance generates heat. The higher the current and voltage you try to pass through a cable or connector, the more heat is generated, like trying to squeeze too much water through a thin hose. The pressure increases and the hose can even burst. In the context of fast charging, if the heat is not dissipated efficiently, it can damage the cable, the connector, or even the device being charged. Engineers had to design USB Type-C and the associated cables with materials and geometries that minimize resistance and maximize thermal dissipation. But how do the device and the charger communicate to decide how much power can be delivered without overheating? That's where USB Power Delivery or USB PD comes in. A smart communication protocol that's the brain behind Type-C fast charging. USB PD isn't just a hardware standard. It's software that allows the charger and the device to negotiate the ideal amount of power and deliver it. Instead of simply providing a fixed voltage, like the common 5 volts we see in chargers, USB PD allows the voltage to be adjusted to higher levels, such as 9, 12, 15, or even 20 volts. And the current can also be varied. This little board here in my hand is a circuit board that uses PD technology, where I can manage the output voltage through a button, and it also uses a charger with PD technology. And I've already made a video here on the channel showing how it works and how you can manage the voltage, and I'll leave a card for that video at the end of this one because it's really cool to see this working. And this is crucial because, as we know from physics, power is the product of voltage and current, as shown in the formula on the screen. By increasing the voltage, it's possible to deliver the same power with a lower current, which reduces heat generation in the cable and connector. Initially, USB PD allowed up to 100 watts, but the latest implementations already support an impressive 240 watts, paving the way for charging high-performance laptops and even monitors. But with so much power flowing, how do we make sure our devices are protected against failures? Safety is a top priority, and the engineering behind Type-C fast charging incorporates robust protection systems. Overload and short-circuit protection circuits are absolutely essential. Overload happens when a device tries to draw more power than the charger or cable can provide, or when the charger tries to force more power than the device can receive. A short circuit, on the other hand, is an accidental low-resistance connection that can cause an excessively high current flow, generating extreme heat and a potential fire hazard. To avoid these dangerous scenarios, USB Type-C chargers and devices with PD technology include power management chips that constantly monitor voltage and current. If they detect any anomaly, they can instantly cut off the power supply, protecting both the charger and the device. But the quality of the physical components also plays a key role in ensuring safety, doesn't it? In fact, the choice of conductor materials is a critical aspect in Type-C engineering. To ensure maximum efficiency and safety, high-quality cables and connectors use materials with excellent electrical conductivity. Copper is the most common and efficient material for the conductor wires inside the cable, because of its low electrical resistance and reasonable cost. However, for the metal contacts of the connector itself, where the physical connection is made, gold is often used. But why gold? Although it is more expensive, gold is an excellent conductor, and more importantly, it is highly resistant to corrosion and oxidation. This ensures that the electrical connection remains stable and low resistance over time, even after hundreds or thousands of years. A corroded or oxidized connection would increase resistance, generate more heat, and compromise fast charging performance. But what happens when we cut costs on these materials and choose low-quality cables? Compatibility and safety are seriously compromised when using low-quality cables. A cheap and poorly made USB Type-C cable may not have the proper copper conductors available. It may use inferior contact materials, or even worse, it may not include the correct identification resistors or the necessary protection circuits. This can lead to a range of problems, from slow and inefficient charging to serious risks like overheating, damage to the device or charger, and even fires. The engineering behind Type-C is robust, but it depends on the integrity of all the components. That's why investing in certified, reputable cables and chargers is essential to safely enjoy the benefits of fast charging. But what does the future hold for this technology? Well, the future of fast charging with Type-C is promising and continues to evolve. Trends point to even higher power levels, with the development of new SBPD specifications that could go beyond 240 volts. Allowing you to charge even more demanding devices, such as portable workstations and even light electric vehicles. In addition, engineering is focused on making chargers even smaller and more efficient, using technologies like gallium nitride to reduce the size and weight of power adapters, while maintaining or even increasing the power. The integration of fast charging into more devices, standardization, and the pursuit of even safer and more durable solutions are the pillars of continuous innovation in this field. USB Type-C is not just a connector, it's a power platform that's shaping the way we interact with our devices. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. If you find it interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you've made it this far, I invite you to take a look at the courses we recommend. So point your phone at the QR code here on the side or click the link in the description for our courses. There, you'll find courses on Excel, 3D modeling, AutoCAD, public speaking, and many others. These are courses selected by us, which we can vouch for their quality. So if you want to boost your career, it's worth checking them out. And have you ever stopped to think about all the engineering behind that little cable that charges your phone in minutes? What's the highest charging power you've seen for a device?
Via USB tipo C.
Leave it here in the comments below and share your experiences. Here on the side, there are 2 interesting videos that you need to watch to expand your knowledge and satisfy your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.